Hey Geometry, this is Mr. Florio, 16.2, maximize in three dimensions. I'm going to kind of answer one and two together. Number one says find a set of dimensions for a rectangular prism with a volume of 60 cubic units. So this is kind of like the cool down before. Can we come up with a bunch of rectangular prisms that have a volume of 60? We're going to calculate the surface area of it, and we're going to do it for a bunch of different rectangular prisms. And the reason why we're doing it for a couple different ones is because of number two. A lithium ion battery, which is kind of like what you see in like cell phones and stuff, a lithium ion battery contains a rectangular prism made of lithium. The energy in the battery is proportional to the surface area of the prism. What that means is the bigger the surface area, the more energy in the battery. So they want to increase the surface area of these lithium batteries. But don't play with these. These things are really dangerous, so be careful. Assume the lithium has a fixed volume of 60 cubic millimeters. Find the dimensions of a rectangular prism with this volume that maximizes its surface area. So up here we are asked to do it one time, and then on the bottom we're asked to kind of find the best possible dimensions here. So if I want to find a rectangular prism and I want the volume to be 60, the volume for a rectangular prism is length times width times height, which is base times height because the length times width is the base. I need these three numbers to multiply to 60. One thing I could do is making it by, I don't know, 6 times 5 times 2. 6 times 5 is 30. 30 times 2 is 60. So that'll work. What would the surface area of that be? Well, the surface area, we'd have to calculate a couple. There's 6 faces. There's like the front, the back, the top level, the bottom level, and the walls on the left and the right. So if I wanted to calculate the area of the top, that's just a rectangle with a length of 5 and a width of 6. So 2 times 6 is 12. The bottom floor is the same 2 by 6. This is also going to be 12. And then we have kind of like the front of it. And this is, the height's 5, so this is 6 by 5, this is 30. So the front face and the back face are both going to have 30, an area of 30. And then we have the, kind of like the side walls. This is 2 by 5, which is 10. This one's also going to be 2 by 5, so that's going to be 10 and 10. So the surface area of that shape is 30, 60, 70, 80, 90, 102, 104. 104. The question is, if we fix the volume at 60, can I alter these dimensions to make the greatest possible areas possible? Obviously, the greatest possible surface area is possible. So I'm going to make a chart here, and assuming that we all did this with different directions in class, here I did a length of 2 by 5 by 6. Whether you call it 256 or 652 or 526, the order doesn't matter. I'm just going to go from smallest to biggest. This thing had a volume of 60 and an surface area of 104. So can we come up with some other ones? So first of all, let's come up with some numbers that multiply to 60. I did 2 times 5 times 6. 2 times 3 is 6. 6 times 10 would give me 60. Let's see. 3 times 4 is 12. 12 times 5 is 60, so that would work. Be a little clever here. 1 times 6 is 6. 6 times 10 is 60. And 1 times 1 is 1. 1 times 60 will give me 60. So these are different dimensions that I could use, and I need to calculate the area of all of these, and maybe I can figure out which one's going to give me the most possible area. And I don't think I missed any, but now we just have to calculate the area of all of these. So the 2 by 3 by 10 one, that'll be this one right here. It's 2 by 3 by 10. So let's see. The front face and the back face are both 2 by 3s. So that's 2 times 3 is 6. So there's 2 areas with a 6. This sidewall is 2 by 10, which is 20. And there's going to be 2 of those, right? There's 2 sidewalls. And then I'll change the color to make it a little clearer. The top here is it's going to be 2 by 10, which is excuse me, front back 6. This is going to be 2 by 10, which is 20. So the top and bottom are both going to be 20. And then the side walls that I said were 20 are not actually 20. This is 3 by 10, right? 3 by 10 right here. So those are the side walls. 3 by 10 is 30, so there's two 30s. So 30, 60, 70, 80, 90, 100, 112 would be that one. So that would be the area. All right, and let's do the 3 by 4 by 5. So this one's gonna almost look almost cubic. It's gonna be very close to a cube because all the lengths are kind of close to each other. So 3, 4, 5. 3, 4, 5. So the area of the side walls is 4 by 5, so that's 20. So there's two 20s there. We're talking about the area here. So that's 20 and that's 20. Let's do a different color. The floor is 3 by 4, so that's going to be 12, which means that's going to be 12 as well. And then we have the front, which is 3 by 5. 3 times 5 is 15, so there's going to be two 15s. 30, 40, 50, 60, 70, 80, 94. So the area of that one's 94. And what are these ones going to look like? These ones are kind of interesting shapes. Let's do the 1 by 6 by 10. So we have 1 by 6. And then we'll make this 10. So that thing still has a volume of 60. 1 times 6 times 10. What's the surface area of that? Well, let's see. This face right here is 6 times 1, which is 6. So we have two 6s there. And then the top here is 10 by 1, right? Because this is 10 and this is 1. So we have two 10s. And that's because the bottom is also going to be 10. And the side walls, this one was the ones with a big area. That's 10 by 6, which is 60. So 60 and 60 is 120, 130, 140, 152. So this is 152. So the question was, we want the lithium battery to have the biggest surface area because the energy is proportional to the surface area. So the bigger the surface area, the more energy. And right now, the 1 by 6 by 10 lithium battery is going to have the most surface area. And it seems like the more we stretch it out, the bigger the area is getting. The more we turn it into a cube, the smaller the area is getting. So I bet this one's going to be even bigger. And if I make it 1 by 1 by 60, 1 by 1 by 60. That'll have that same volume, but now I need to find the surface area of it. All right. The surface area, this is 1 by 1. So that's an area of 1, and that's an area of 1. So we have 2 right there. The top is 1 by 60. So the bottom's also 1 by 60. In fact, the sides are also 1 by 60. So there's actually going to be 4 60s. And those are all 6 faces, and if we add those up, that's 242. And that was the biggest area. So the question was, what is the surface area and what are the dimensions to maximize it? The dimensions are 1 by 1 by 60, and the surface area you get is 242. Kind of interesting thing about this is if we didn't want to use integers, so we let the dimensions be all whole numbers, but what if we took dimensions like a half? If I could make these two dimensions smaller, instead of 1 by 1, make it like a half by half or a fourth by a fourth, that would stretch out this 60 right here even longer to make that have the same volume, and then that would increase the surface area even more. So if we could use non-whole numbers here, which in the real world, why not? You can make that thing as long as possible, and the longer you make it, the more surface area you have. So the important takeaway is that to maximize the surface area for a set volume, the volume was set at 60, a shape could be made flat and long, and that's how you make the area bigger. For a battery to accomplish this, they need to make the lithium into a thin foil that can be rolled up to fit inside the battery. So they need to make it really, really long like this, and then they can roll it up, and then that's how you could save storage space. So the point here is that we can pack as much surface area as possible into a small volume, and we can do that by folding. So like if you were to have a lithium-ion battery, not even just with that, but for example, the chemical reactions that occur in the mitochondria to provide energy to cells in our bodies take place on the surface, which is why the inside of the mitochondria has many folds. Likewise, the chemical reactions that occur in the brain happen on its surface, which is why the brain has many folds. Intestines absorb nutrients through the surfaces, so they are folded to pack as much surface area into the digestive tract as possible. So a lot of things need to, with a set volume, increase the surface area, and one way you can do that is by stretching it out and then kind of folding it.